Hello everyone, this is Devin Foss, and today we'll be covering some pre-cal practice problems. In the description of this video, there's a document that contains these practice problems, and I recommend you do them before you watch, so that whenever you are watching the video, you can get an explanation if you need help on anything. I won't be covering all of the problems, but there should be enough to where you'll get a good understanding of vectors and their applications. So without further ado, let's get started. So part 1 is going to be covering basic vectors in geometry. So the first question says if A, 9, 4, and B, negative 5, 2, then what is 5A plus 4B? So this is pretty simple. The vector A is being multiplied by 5 and B is being multiplied by 4, so you just multiply the values of those vectors by 5 and 4 respectively, and then you graph them, and if you want, you don't have to, but you just add up the two values, like here and here and here and here, and then you'll get your answer. So we'll take our first vector, 5a, we graphed it out right here, came out to 45, 20, which as you can see 45 and 20, and then from that point we graphed our other vector, which is negative 28, and that leads us to 25, 28 if we start from the origin, which and that's what that's our answer that we got when we started doing all the addition. So that means that this is a logical answer, and our answer is 25, 28. Next problem is also very simple. It's just determining the distance of the vector v, which is 4, 3, and negative 1, so it's a three-dimensional vector, but that doesn't really matter because it's the same formula anyways. So it's just v of x squared, v of y squared, and v of z squared, which is just 16 plus 9 plus 1, which is root 26, and that's a pretty logical answer given about how far that vector would be going. Alright, now we have one of the harder questions, trying to get into the more difficult questions. So determine the degree measure of the angle between the vectors g and h. So first, let's find the distance of our vectors, and then we can do a tip-to-tip, or tip-to-tail triangle, and then we'll solve that way. So for g, we just do square root of 81 plus 25, which is 9 squared plus 5 squared, which is 106. H, which is this, is just 49 plus 1, which is 50, or 5 root 2, but we're just keeping it in 50 for now. And we're also going to add another one called I, which if we go to this picture right here, you can see that I drew out the triangle. This is G, or sorry, this is H, this is G. Well, no, this is G, and this is H, and this is going to be I, since we're connecting the two to find this angle. So we'll first find the distance of I, which is this right here. It comes out to be 272, which is 4 root 17, but again, that's not necessary for reasons that will be clear right now. To solve this angle, we have the known values of three sides. We know I, we know G, we know H. And so we can use the side law of cosines rule, which is just using this formula, which is I squared equals G squared plus H squared minus 2GH cosine I. I and I squared are opposite of each other, so this is the angle, this is the side. So you take these three values, you plug them in here, and then here, and then we solve for I, so you do 272 equals 50 plus 106, because the square roots cancel out because they're being squared, minus 2 times root 50 times root 106 times cosine I. That simplifies to 116 equals negative 2 root 5,300, which we keep simplifying down to cosine I equals negative 58 over 5,300. Rationalize it, so we get negative 58 root 53 over 5,300 equals negative 20, simplified by the way, equals negative 29 root 53 over 265. And then to solve for I, we just do the inverse cosine of negative 29 root 53 over 265 equals 142.815. This is going to be our answer in degrees. And it's important to note that we'll be covering the inverse cosine multiple times in this video. So if you have cosine and it's whatever's inside the cosine on one side, you can just take everything on the right side, put it in brackets, and then make a cosine inverse, and then plug it into a calculator, because this is the best we can do. So this is the approximate answer. Looking at this picture, if you draw a picture, you will also see it's pretty reasonable. This is a pretty big angle. This looks good. So checks out. So let's move on. Next problem. So given the vectors 4, 6, and 3a, use the dot product to determine the value of a that makes the vectors collinear. Now, I have two methods here. One of them is very long, and one of them is like 4 steps, and it's just a bunch of words. So let's cover the long one first, because this is the one that this is the one that you'll be using to solve harder problems, and not something that you can be eyeballed like this. So to find the a value that is collinear, we have to know that the dot product a times b is equal to distance A, distance B. So let's find that real quick. Distance A is root 52. Distance B is not root 9 plus a squared. So this is we can't do much with this. We have to leave it like this. And then we'll find and then we'll multiply these together to get what we need to equal to a times b. So we got um, 52 or root 52 times 9 plus a squared in the root is equal to 468 plus 52 a squared, also in the root. So this is going to be what we need to get a times b to equal. We need it to be this. So for the dot product formula, it's just ax times bx plus ay plus times by. This is the easy one that you can do. There's also one that uses cosine, but we don't know the angle, and we don't want to figure out the angle, so we're just going to use this one. It's very easy. Um, so we plug in the variables. 4 times 3 plus 6 times a is just 12 plus 6a, and then we make these two equal to each other because this is what they have to be. So 12 plus 6a equals root 468 plus 52a squared. And then you just take out the roots, so square both sides. 144 plus 36a squared equals 468 plus 52a squared. Simplify, that's just, or simplify and combine, that's negative 16a squared equals 324. You can divide this side by negative 16 and then simplify to get negative 81 over 4, and then you just root both sides. A is equal to 9 over 2, or 4.5. But there is also a cool thing that I noticed. So the two if the two vectors are collinear, which means that the angle will be 0, so that essentially means you have one vector. Imagine it is going, let's say, from 0 to 1, like here to here. From here to here, and you have another vector that's going from 0 to 0 to 2. Well, 2, 2, and 1, 1. They're going to be overlapping each other, and that's what they mean by when they say collinear. So if we have 4, 6, it's going 4 this way and 6 this way, and we have 3a, well, we know it's got to be somewhere that's intersecting with the 4, 6 vector, so we can just so we know that the vector, we'll call this b, is scaled to 4, 6, and scaled down because it's or it doesn't even matter. We can just find the relationship between 4 and 6 and then multiply that by this value, and then we get the answer. So 4 times 3.5 is 6, and then 3 times 3.5 is 4.5, which checks out with our math. So that's a little cool thing on collinears, and might save you some time if you get a problem like this. Okay, next, given the vectors that are the same, we're going to find the dot product, are going to use the dot product to determine the value of a that makes the vectors orthogonal, which is perpendicular to each other. So this equation is a times b equals 0. So all we got to do is just use that other equation, this thing right here, and equate it to 0 and then solve. So 4 times 3 plus 6 times a, it's equal to 0. So that means that this is 12, this has to be a negative 12. 6 times a is negative 12, a is negative 2, boom. Next. Alright, so now we're going to work with angle of elevation and deprecation, I think it is. I'm not sure, but so we're going to do these problems. You've probably seen them before. So this question says a skyscraper is 553 meters tall. So let's suppose that at a certain time of day it casts its shadow 110 meters long on the ground. What is the angle of elevation of the sun at that time? So for me, I like to draw, but you don't have to draw it out. This is if you're proficient enough, but this just kind of helps you put all the numbers in the right area. So this is our building. This is the shadow, 110 meters long. Building is 553 tall, and then we got to find this angle. So yeah, that is, it's a right triangle, so it is literally just tan x, opposite over adjacent. SOHCAHTOA, we all know this, um, or maybe not, but it's good that we're learning it now. And then we have tan x is just 553, which is the opposite over 110. We can do this little maneuver again, where you just go x is tan inverse of all this, and then it gives us to be about 78.75, which is, yeah, that's very reasonable. This is almost 5 times this, so it's reasonable that this is that much of a angle. So that is logical and it does check out. Next, we're going to be asking the same question, but we're gonna be um, seeing the angle whenever it's 270 long. Don't get confused by the wording. It is the same question, but you just replace the 110 with the 270. Do the same thing. Get to be about 63.97. Again, this is our approximate, always to the thousandth. This is our exact answer. And this is logical again. This seems pretty good. It's less than the last one. It's getting over there because this is 270. This is 553. If you even think about how isosceles triangle, or sorry, 30, 60, 90 triangles work, this does match pretty well. All right, next question. Okay. In triangle DEF, measure angle of E is equal to 78. The measure angle of F is equal to 46. Sorry, that should be capital. And F is equal to 138. So determine the length of side E. So we've got, this is our triangle. I drew it out. We've got DEF. We don't know D, but we know E and F, so 78 and 46. Just plugged it in, and we know that um, F is going to be 138. That should be here, but so that's my bad. That's not correct, but it will give the same answer. It does not matter. Or it does matter, but this is just an incorrect drawing, so this should just be here. Math is correct. So we're gonna have to use the law of sines because we have side angle, but we do need D because we have to get. Imagine if we didn't know D, this was over here. We need to find this, so we have to. Oh well, I guess maybe I did do this wrong. Well, anyways, let's just see what I was thinking. Maybe I just did something incorrectly. Um, E over E. You know that E is 78. Sine D over D. Sine E is 78. Sine D is 3. All right, yeah. So I actually did mix up these values. So this is actually one that is wrong. I am sorry. I will make a correction in the comments or the description of this video. That's why you should always be very careful with your labeling whenever you're drawing things because you could mix things up. That is on me. So let's move to the next question. All right. So this is one of the hardest questions that I came across. It said in the diagram below, which is this one, AT is I'm not sure how to say it, but I know that it means that the ratio of A to T and T to C is 1 to 3, meaning for every 1 ATs you'll have 3 TCs, even though it doesn't look like it. It also says that this is X and this is Y. So this is AB, this is BC. Got a little cut off, but it's clear here. And so we have to find this and this, which is AT and BT in terms of X and Y. So what do we got to do here? This looks like a big mess. What do we got to do? First, let's find AT and TC, respectively. We know that this is probably a right triangle because if it I mean, this is a right triangle. If it's not, then that's not fair. This is X, this is Y, so that means that using Pythagorean theorem, this has to be X squared plus Y squared equals, we'll call this Z squared. So let's do the math on the right over here. So ABC is presumed as a right triangle. For every one AT, there are 3 TCs. We just covered this. And then we're going to find AC, Pythagorean theorem. We'll call it ACZ. So going back to this, this is, we'll call it Z for the time being. Z is just x squared plus root x squared plus y squared. So seen right here, this whole thing is x squared plus y squared. Now let's find TC and AT. So 3AT is 1 TC, but you also have to remember that AC plus TC has to be AC. The easiest way I figured it out is just divide it by 4 and then multiply by 3. So these two add up to be 1 over, or 4 over 4 And then you see this is 1, multiply this by 3, you get this, so it's just x squared plus y squared over 4, and 3x squared plus y squared over 4. Um, sorry, root x squared plus y squared over 4. And coming back to here, I labeled those right here and here. So now we know AT, now we know, so we just need to find BT, and we'll do that right now. So we have AT, we need BT, and we know from ABC that tan A is y over x. That's this thing right here. This is y over x, tan opposite over adjacent. Um, and so that means that the angle A is equal to inverse tan of y over x. That sounds like kind of not simplified, but remember, we're just going to be using that as a reference to this angle whenever we can use the other trigonometric functions with this. So we'll use this later on. But that's just the reference to know that we're speaking of angle A and triangle ABC. Next, um, we can focus on ABT because that's what we're just trying to find BT. We can just use ABT and use trig to find that out. Um, and we need to find A, so we'll use law of cosines because we have a side angle side. All right, we'll call BT A in accordance with triangle ABT. A squared is B squared plus T squared minus 2BT cosine A. That's just law of cosines. So we'll just start plugging. A squared is B squared, which B squared is, let's see, it's this opposite of B, which is x squared plus y squared, square root x squared plus y squared over 4. So we know b squared is going to be root x squared plus y squared over 4 squared. T is x. That's opposite to angle t, so that's x, which is just x squared. And then subtract 2. This is b, which is same as here, and then x. Cosine a. And then we already said that a was inverse tangent y over x. So we'll put that right there. And then we got to simplify. So 2 root x squared plus y squared over 4 x cosine tangent over negative 1 y over x can be simplified the cosine tangent inverse tangent thing can be simplified because we are referring to this angle in this triangle. So if we have it's just asking us for the cosine of angle A in this triangle, which is just adjacent over hypotenuse. So so that's just going to be x over x squared plus y squared. The square root of that. And that sounds like a mess, but it's actually cool because it cancels out. The root x squared plus y squared actually cancels with the x squared plus y squared over here. So you cancel those out. You can reduce, multiply those, x squared over 2. All right, looks great. What are we doing over here? This is just algebra. A squared is root x squared plus y squared over 2. Over 4 squared plus x squared, and then we have to add this little minus x squared over 2, and then we can combine these to make x squared over 2, but positive. That's just a little simplification. Helps us out right here when we simplify this by squaring this and this into x squared over 2 plus y squared over 2 plus x squared over 2. And these two combine to x squared, and then all we have to do is square root both sides. So here's the part that is most tricky is that whenever you square root any value, you can only take you can take the positive or negative root of that because you can do positive x squared times positive x squared or negative x squared plus negative x times negative x squared to get I guess it would be x to the fourth. But if you take this value, it can be positive or negative. So we have potentially 4 different solutions, and I'll go into that next slide. But the solution I came up with, and please feel free to correct me in the comments, is A is x minus y root 2 over 2, rationalizing the root 2 in the denominator. So, y plus or minus, when we take the root of something, we have to consider the root could be 2 positives or negatives. That's 4 combinations of positives and negatives. And how can we pick? Well, I just use common sense. Root 2 over 2 is about 0.7, so that's multiplying whatever it's multiplying. It makes it smaller, and so that's being multiplied by the y. If we look back at our graph, we can see that bt is going to be less than x, but it's not going to be it's going to be only by a little bit. So we can't add, we have to subtract something from x to get our BT. And so whenever we look at our equation over here, um, if we subtract y, that would be too. If we subtract x from y, that'd be too little. If we subtract, if we subtract both of them, that gives it negative, and we can't have that. If we add, that gives it too large of a number, so we have to do x squared minus the y. So x is ab, so it is only x minus a little bit of a number, which is just going to be y times root 2 over 2. So yeah, that's our this is our BT, and that's the whole problem. Uh, I hope that made sense. It made sense for me. Uh, Again, feel free to correct me, but that is the answer that I found to be most reasonable. All right, next problem. We've got a line AB is represented by the equation 4x plus 5y is 20. If A is the y-intercept of the line, find one of the possible points. There are two for P, which A is orthogonal to AB and the distance AP is equal to 1. So let's convert this into slope-intercept form because it looks nicer and it's easy to work with. At least in this scenario for me. Maybe it isn't for you, but I like doing things in slope-intercept. Y is equal to negative 4x plus 4. Yeah, so the slope, we know from the law of of how perpendicular lines are, the negative inverse of 4 over 5 is 5 over 4, and that's going to be the slope of AP. Because it is orthogonal, it is perpendicular. They're almost interchangeable, almost. So we know line AP is going to be running perpendicular and make a right angle with our line AB. So we know A is equal to 4 because it's the y-intercept, and so that's just 0 for the x and 4 for the y. And here is whenever some people I realize that they don't really know what they're supposed to do after this. We can actually use systems of equations because this right here, this is our distance formula for our AP line. We know our AP line has to be this distance. It has to be 1. And if I go to the next slide, here's a little picture. This is AB. We'll just say, let's say A is here and B is here. A has to be here, but B could be anywhere. And then we're trying to find where P is along this line. So, as you can see, the two answers are negative or positive. So we know it has to be somewhere here because that's where it's going to be 1. Uh, this right here, this distance is actually, you can actually make it into a graph. It's actually a circle, and it's a circle around the y-intercept. If you do a little bit of research on that, you won't always have that knowledge, but you should just know that it has to be a system of linear equations, and this is or not linear, just a system of equations. This is a system right here, just using the original 5 over 4x slope, because if this is our line, we know that and we have, let's say, the distance formula makes a circle right here. Wherever they intersect, which is going to be somewhere here or here, we know that that's going to be where our P spot is, or the point P will be. So we just do a little bit of solving. We know that y is going to, we already have y solved for us. 5x over 4 is 4, so that's why I did that, because it's easier to solve because we already have y there. And then we just plug, and then do all this simplification. I don't think I need to go over this. We've done it enough today. We just get this number right here. This is the exact number for root 41 over 41, rationalizing the 41. It's approximately 0.625. Approximately. So that's about where we predicted it would be. The x would just be a little bit to the right, and the y is a little bit more than 4, closer to 5. If we plug right here, and this is our point. It's 0.625, 4.781. That's right about here. That looks like this is going to be too much. That's going to be more than 1. This looks like it'll be right about 1. So this is a logical answer, and this is our exact answer. If you can't use calculators or decimals, this is our exact. It's a little clunky, but it services. All right, next we're going on to part 2. Part 2 is going to cover law of sines, cosines, ambiguous case bearings, and areas of figures. We already did this a little bit in part 1 with the law of cosines, but we're going to do it more in this part. So let's start. So our first question says an isosceles triangle has a length of 8 cm, 8 cm, and 12 cm. So 2 eighths, it's an isosceles, as it said. Find the measure of the base angles, which are these two, right here. And then this is side, side, side. So it's law of cosines, but it's relatively easy. You just simplify this thing right here. This is basic level math. Not, I wouldn't say basic, but it's very easy to simplify. 64, 204, when these two combine, minus 192, and then is equal to cosine x, and then we just subtract, divide 144 over 192 is cosine x, do the inverse cosine maneuver, and then you get about 41.410. This makes a lot of sense because this is going to be our big angle. These two are going to be our smaller angles, and that seems about right. Cool. This one's pretty simple to do, but it is easy to mix up that inverse cosine at the end. So make sure you do that. Next, we have another elevation deprecation problem. This one is deprecation from the top of a cliff. Uh, or it's depression. That is my bad. It is depression. From the top of a cliff, the angle of depression of a house in the valley is 75. So that means that from the top, we're looking. This is our line. We're looking down. This angle is 75. We see the house here. The house is 110 feet from the base of the cliff. Determine the height of the cliff. So this is what we did earlier, but instead of having this unknown, this is the unknown. So it's just tan 75 because it's a right triangle. Tan of this angle is opposite over adjacent. So it's x over 110. 110 tan 75 is x, and then plug it into the calculator. Is 410.526, and that is a very logical answer. This is a lot more than this. That's good. Awesome. Next problem. So we're going to determine the number of possible solutions of ABC if measure of angle A is not 84. A is, I'm sorry, that should be capitalized again. A is 43.68 inches, and B is 28.64 inches. This is the ambiguous case. So we have a angle, and we've got a line, and this our opposite side to the angle is going to be somewhere on this line. So what do we got to do to find the number of solutions, you may ask? Well, it's pretty simple. All we have to do is find b sine a, which is the height. So that's this times the sine of this, and we'll just plug it into your calculator, or don't, and just use it as it is. Don't and be exact. I don't know how you would find that, but you get this value right here, 28.483. That's our height. And so now we to figure out if how many solutions we have to compare it to h. We have to compare our side that we're trying to fit in somewhere along this line, which is 43.68. We have to compare it to we have to compare it to B, which is this, and H, which is this. So we know that A is greater than H. So we know we have at least one solution, because if it was less, then it would never touch this line, and we would have zero solution. And A is greater than B, so there's one solution. If it was less than B, then we could have it either here or here. But since it's greater than B, we can't have it going this way, because then this angle will get messed up. So it's just this. All right, let's move on to the next problem. A surveyor measures the three sides of a triangular field and gets 114, 165, and 257 meters respectively. What is the measurement of the largest angle of the triangle? So, we have to remember that the largest angle is opposite to the longest side of a triangle, and we have three sides, so that's law of cosines. A is going to be our longest side, 257, and capital A is going to be our angle. So, plug it in. 257 squared equals 114 squared plus 165 squared minus all this. Yeah, we know how to do this. You get these two pretty big numbers times cosine, or this number is equal to this number times cosine A. Cosine A is roughly equal to negative 0.68 whenever you divide these two, and then you just inverse cosine, and then you get your angle measure. And this is pretty logical because 257 is quite larger than 114 and 165. And 113 is a pretty big angle, but it's not like super, super big. So that's a pretty solid answer, I'd say. Okay, next. We have two planes leaving an airport. This is our bearing question. One is heading with a heading of 40 degrees, traveling at 450 miles per hour, and another heading of 300 degrees, traveling at 500 miles per hour. Determine the distance between the two planes for 3 hours. So this is our little, our little map right here. This is our starting point. We're gonna have this line right here be our reference angle 40 degrees off the reference angle is going to be this line right here, and then 300 degrees, or negative 60, is going to be this right here. Plane 1 traveled 1,350 miles because it went 450 miles per hour and then 3 hours, so that's just multiplication, and then plane 2 went 1,500 miles. So this is side angle side with the angle being 100. Set up that SAS triangle, law of cosines. We've done this multiple times today. You already know the drill. You solve it. You get this. You root it. You get x equals 2,185.35. And this is a logical answer because, again, this is 100. It's greater than both of these numbers. It looks like that's a reasonable answer, so always make sure that you're checking that it sounds good. Alright, we have another ambiguous case problem. If two non-congruent triangles have a measure angle of A, which is 62, side A is 16.6 feet, and B is 17.3, what is the area of the triangle with the greater perimeter? So here's a little confusing of what it's asking for you, but really we're doing the same setup twice, but we're going to have two solutions. So, like all ambiguous cases, we find B sin A, 15.275, and from there, we can compare our values. So this is B, and A is going to be 16.6. So A is greater than the height, so we can have a solution, but it's not greater than B. So it could go here or here, as I drew right here. It could have two possible solutions in the middle, one being obtuse and one being acute. And so from this triangle, we'll work with the acute one because it has a larger perimeter, because it'll have a larger base. Yeah, pretty simple there. But we have to use law of sines to find the base because we don't have a base here, so we got to use law of sines. So sine of but first we have to find another angle because we can't use, these are two unknowns. Angle C and side C are unknown, so we have to find at least one of them firsthand. Can't find the length of the side without using our law of sines, so we got to find at least angle C. But to do that, we gotta first find a separate angle to use our triangle properties, which is the three angles add up to 180. So we'll have to find angle B first. Sine 62 over 16.63 or 16.6. Sorry. Opposite, as you can see in the diagram, is equal to sine B, which is this angle right here, over 17.3, because our law of sines is, as was mentioned in the wrong problem that I did, my mistake, was sine A over A equals sine B over B, which is sine C over C. So yeah, we can use that ratio. Find sine B. Sine B is this number, and then use inverse to find the angle, which is 66.953. So we'll use that. That goes here, and then use 180 minus 62 plus 66 gets 51.047. So that's C, and then we just do the same thing, C, but this time it's a little easier. We can just cross multiply, get C to be 14.621. So that's the base. That's cool. This is going to be our smallest this is going to be our smallest angle, so this is going to be our smallest side. So that makes all of the sense. It's very awesome. So then it's just area. 1/2 base times height. 111.668. That sounds good, because if we think about it, let's say 14.621 times 15.275. That's about 200 something. So that would be the area of a square or parallelogram with those dimensions. So yeah, and we're just cutting that in half. So sounds good. All right, we're almost at the end. We've got one more. We've got our last angle of depression problem. A lighthouse keeper 100 feet above the water sees a boat sailing in a straight line directly towards her. As she watches, the angle of depression to the boat changes from 25 to 45. How far has the boat traveled? So, let's draw our two lighthouses. This is 100 feet. It's X distance away at an angle of depression at 25, so that means that this angle is 25. Find X. It comes out to be about 214.451. And then we find the distance to the boat at 40, and that's finding Y. and that comes out to be about 119.175. Subtract y from x because we want to find this segment right here, this little thing. Um, and so that's just subtraction. 95.276 seems like a good answer. Thank you all so much for watching. I hope that you enjoyed. I hope you learned something. I hope that we all got smarter and will do well in our tests and all that. Again, I did make a couple mistakes, but I'll be sure to correct those in the comments for you all. And if you have any suggestions on maybe any future discussions of math and pre-cal, if there's anything that you need me to do, like let's say you want to have a more in-depth slideshow, you want it to be less in-depth and make it quicker, please let me know. I hope you all enjoy it. I hope you guys have a great day, and I'll see you later. Thank you.